Hi there boys and girls, and welcome to iTTV. You're with me, Mr. Joel, your tutor for Mathematics Form 4. Alright students, today we'll be looking at Lesson 6 of Chapter 1, Standard Form. And this is our final lesson for this chapter. We're going to continue where we left off from Lesson 5. Alright, in Lesson 5, we have looked at two types of computations involving numbers. Right? The first one involves plain numbers, and addition, subtraction, multiplication or division. In type 2, it is actually involving numbers which has already been converted to a standard form. So we have looked at type 2 where it involves multiplication and division. In today's lesson, the operations involving the numbers in standard form are involving addition and or subtraction. It means that we're going to actually add or subtract or perform them both to two numbers in standard form. Alright, in order to do that, there are two methods to perform the operation. For method 1, the first step is ensure that the index numbers are of the same power. In step 2, carry out factorization, and in step 3, carry out the appropriate operations. So there are actually 3 steps. Alright, now let's look at our first example where we'll do it together. Find the value of each of the following and state your answer in the standard form. Alright, here we have 6.5 times 10 to the power of negative 2 plus 3 times 10 to the power of negative 3. Alright, now let's do this together. Alright, now we have actually here addition of two numbers in standard form. We have looked at the first type, which is multiplication and division of two numbers in standard form. Today we are going to look at addition and subtraction of two numbers in standard form. And as I've taught you all earlier, identify the two numbers in standard form. This is one number and this is another number. So we are actually going to add two numbers which has already been converted to standard form. And remember the 3 steps, right, in order to find the value. Alright, the first step, check whether the indices, which means the power, okay, of the number in base 10, are they equal or not? Because if they are not equal, we cannot find the value using method 1. Method 1 involves you must always make sure that the index is of the same number. They are the same thing. So it is not the same. One is negative 2, one is negative 3. So our second step is we must convert and we must standardize it so that both numbers have the same index. So in order to do that, look at the smaller index. Negative 3 is smaller than negative 2, right? And then now we are going to change from negative 3 to negative 2. So this first number in standard form, we don't have to do anything because it is fine the way it is. So 6.5 times 10 to the power of minus 2. Okay, now for the second one, we have to convert it from minus 3 to minus 2. So we must edit it a bit. Alright, so when 3, the point is here, in order to make it just go back 2 places, we need to put the point 1 step behind. And thus it becomes 0.3 times 10 to the power of minus 2. So now we have already standardized. Remember, guys, these are the same numbers. We have just changed the form so that we can perform the operation. Okay, next, factorize. And what does it mean by factorize? Factorize means we factorize the numbers. And this can only be done once the index has been standardized. Once it is done, factorize. Take out the two numbers. And because the index is already the same, it is by itself there. Alright, and hence perform step 3, the operation or operations that are needed. 6.5 plus 0.3, 6.8 times 10 to the power of negative 2. So don't forget the 3 steps involving addition. Alright, now we are still in type 2, where we are going to add, subtract, or add and subtract 2 numbers that are in standard form. But now we come to method 2. We have just looked at method 1, where it involves 3 steps. We have to standardize the index. For method 2, there are only 2 steps. The first one, convert the numbers which are originally in standard form back to their single numbers. And step 2, carry out the operations. And state the answer obtained in standard form, which is the last step. Alright, now let's look at this example. Find the value of each of the following and state your answer in the standard form. Alright, it is 1.23 times 10 to the power of 4 minus 9.4 times 10 to the power of 3. So it involves subtraction of 2 numbers in standard forms. How do we do and find the answer using method 2? Let's proceed to the board. Alright guys, now look here. There are 2 numbers. Remember, if there are no brackets, make the bracket yourself so that you will be able to identify the 2 numbers in standard form. Obviously, this is one number in standard form. Okay, you know it. And another number in standard form. So now we're going to use method 2. This was method 1. For method 2, the steps are convert both these numbers in standard form back to their original single numbers and then only minus. So if it is 1.23 times 10 to the power of 4, you know that in order to change back, positive 4 is moving back 4 places. So there are actually 2 zeros. Okay, back to its single number. Rewrite minus, and 9.4 times 10 to the power of 3, positive integer as the index, move 3 places to your right, and it will be 1, 2, there's 1 0 there, and another 3, 2, 0. So it will be 9. Alright, once you have converted it back to its single numbers, it is easier to perform your operations. So using your calculator, what is the value of the subtraction of these numbers? You will get 2,900. Alright, now convert it back to its standard form. So you remember how to convert? Put the point, and then we need to move 3 places to your right. Alright, so these are actually 2 methods of finding and performing operation involving plus and minus of any 2 numbers which has already been converted to standard form. Alright, sometimes we have to solve problems involving numbers which has already been converted to standard form. Let's look at this example. Alright, the mass of a minute particle is 2.3 times 10 to the power of minus 3 grams. Calculate the mass in kilograms of 8,000 such particles in a plastic bag. Express your answer in standard form. Alright, this is a problem involving standard form because you are required to express the final answer in the standard form. Alright, so analyze the question carefully. The mass of 1 minute particle. How heavy is it? 2.3 times 10 to the power of minus 3 grams. Now, what is the mass of 8,000 such particles in kilograms? So let's take a look at the solution. The mass is 2.3 times 10 to the power of minus 3 grams times 8,000 for 8,000 such particles, and then divided by 1,000, because 1 kilogram is 1,000 grams. So we need to divide it by 1,000. Alright, simplify the calculation according to the Bodmer's rule, and the final answer of 8,000 such particles will be 1.84 times 10 to the power of negative 2 kilograms. Alright, now we have come to a quick test segment. Students, you please try this yourselves. Find the value of each of the following and state your answer in the standard form. Alright, 1. 8.72 times 10 to the power of 4 plus 5.93 times 10 to the power of 6. Remember, you can choose method 1 or method 2 to find the answer. It's up to you. What is your answer? Right, please compare. You should get 6.0172 times 10 to the power of 6. Alright, another one. 3.6 times 10 power of minus 3 minus 9.4 times 10 to the power of minus 4. Alright, choose which method you want and compare your answer with my answer. You should get 2.66 times 10 to the power of negative 3. Alright, now let's continue with our example. Find the value of each of the following and state your answer in standard form. Right, you have question A, 7.25 times 10 to the power of minus 3 plus 9.6 times 10 to the power of minus 5, and B, 3.6 times 10 to the power of 5 minus 9.4 times 10 to the power of 2. Alright, come, let's do this together. Alright, now we have another two questions and you should be able to identify how does it look like right now. Alright, because we have in A an addition of two numbers in standard form. Alright, let's identify the two numbers. This is the first number in standard form and the second number in standard form. Alright, to recap the two methods to get the numbers, alright, I'm going to use method 1 for question A and method 2 for question B. In method 1, remember the three steps involve checking the index. If it is not the same, the power, we cannot perform the operation. So the first step is always to standardize the indices. And you can standardize either way, but it is better to standardize from the smaller index to follow suit the bigger index. So in order for that, we just rewrite the number that does not need to be converted. Okay, it is already minus 3. Now we need to standardize minus 5 to make it minus 3. In order to do that, we must actually shift the decimal. Alright, to change back to a single number, we need to move the point 5 places to the left. 1, 2, 3. In order to just move back 3 places, the point needs to be 2 steps further in front, which is 1, 2. So there's a 0 here. So it becomes 0.096 times 10 to the power of negative 3. So this number and this number are the same. This is the standard form and this is the form that we just changed so that we are able to perform method 1 to find the answer. Okay, now next step, remember, factorize. Once you have changed them both to the same index, you can add or subtract according to the numbers that are in the brackets. Okay, and then rewrite minus 3. Okay, and then perform the operation inside the bracket using the calculator. And lastly, check it. Is your final answer already in standard form? And yes, it is. Why? Remember, A is already between 1 and 10, and everything else follows the method of standard form. Alright, now guys, let's look at B. And I'm going to use the second method to find the value of the subtraction of this number from this number. So always identify your two numbers in standard form. And now for method 2, we are going to change both these numbers back to their single numbers before we subtract. So 3.6 times 10 to the power of 5, what will it be? 3.6 times 10 power of 5, remember 5, move 5 places right. 1, 2, 3, 4, 5. So it is 360,000 minus 9.4 times 10 to the power of 2. 2 positive, it's 2 places to the right. 1, 2, add a 0. So the decimal has already been pushed at the back. So once you have converted back both to single numbers, use your calculator and perform the necessary operation. Alright, what do you get? You should get the answer on your screen. And then finally convert it back to its corresponding standard form. Okay. Alright, remember when you determine the index, how many places must you go? 1, 2, 3, 4, 5. Alright, you can compare your answers. Alright, you should be getting it. So remember guys, there are only two methods when it comes to adding or subtracting of any two numbers in standard form. You can choose which method you want or you are familiar with, method 1 or method 2. Alright, now we have come to one more question. The length of a river on a map of scale 1 to 5 million is 4.5 cm long. Find the actual length in kilometers of the river and hence state the answer obtained in standard form. So we have looked at one problem earlier. This is one more problem involving numbers that require operations in standard form, and let's do this together. Alright guys, now read the question carefully. The length of a river after it has been drawn on a map is 1 to 5 million. So now the scale that is used is 1 to 5 million. What does it mean? This means on the map, 1 centimeter in real life will represent a length of 5 million centimeters. And now there is a river right on this map, and the river on the map is 4.5 centimeters long. So actually, okay, on the map this would be 4.5 centimeters. How many kilometers will this river be in real life? So we need to perform operations involving numbers in standard form. So since 1 centimeter will give you 5 million centimeters in real life, 4.5 centimeters will give you 4.5 multiplied by 5 million centimeters. So now using your calculator, what is the length of this river in centimeters? So it is 4.5 multiplied by 5 million. So in centimeters, the answer is very big. But since now the answer requires you to state the final length of this river in kilometers, we have to divide by a certain number. And now, how many centimeters are there in 1 kilometer? Let's check it out. In 1 km, you know it has 1,000 meters, and each meter contains 100 centimeters. So in short, 1 km will contain 5 zeros. So it means 100,000 centimeters. So if this river is 200, 2250 and 40 centimeter, to convert it back to kilometers, we need to take its length in centimeter divided by the scale of conversion to kilometers. And now, what is the length of this river in kilometers? You should get 225 km. It means that in real life, once we have converted from 4.5 cm, the actual length of this river is 225 km. But don't forget guys, because you have to state the final answer, which is 225 km, in a standard form of writing a number, which is actually 2.25 times 10 to the power of 2. So you can compare your answers here. It's 2.25 times 10 to the power of 2 kilometers. So with that, we have come to the conclusion of lesson 6 for chapter 1. So today we have looked at two basic operations involving numbers in standard form, which is primarily addition and subtraction. And once we know how to perform operations, we can use it to solve problems involving numbers, where standard form is very efficient in finding the answers. So thank you, and we'll look at the next lesson. It's goodbye for now.